Hello, good evening, everyone. So, let me share the link with the students, right? We will start the class after 2 minutes. Huh? Sure. Okay, let me share the link. Am I audible to you? Let me know, please. Is it audible? Yes, fair. So, yes. बाकी लोग को क्लास ज्वाइन करने देंगे. We will start the class after 2 minutes. Fair. Okay. Is it visible? Everything fine? So today we have to discuss problems. Let them join the class. Good evening, Shubhranshu. Good evening. Where is Sivu? So today we will do problems. है ना, Shubhranshu? Actually, today we will finish this topic. Differential equations of first order but not of first degree. पहले तो मैं इसको चलिए. Okay, let's start. है ना, Shubhranshu? Let's start from the previous lecture itself. Is there any doubt from the previous lecture? Shivu, Shubhranshu? Any doubt that you want I have to revise or something like that? Please do let me know. Otherwise, let's start. Today also I will be using those methods whichever I have discussed yesterday. So if you have any doubt in that, do let me know. Chale. Let's solve some question that they asked in the IIT exam. It's 93. So what they ask, find general and singular solutions of 8a PQ equals 27y. Fair. So in the UPSC, how they ask? They will ask you general and singular solutions. So the theory part we have discussed yesterday very well, I guess. Today I will be focusing on problems mainly, right? So solution. What is the step one, my dear? Step one is finding the general solution of 1. How we will find the general solution? Either of the methods, solvable for p, solvable for y, solvable for x, or through the Clairaut's form, right? So if we observe this differential equation, so this is simply variable separable. If I write 8a in place of p, I write dy over dx, and that goes to 27 by. So if I write this as dy over dx, it will become 27 by divided by 8a whole raised to the power 3, right? स्क्वायर तो नहीं है कहीं पे, चले. So now variables are separated. Square किसमें आ रहा था? 3 8ap fair. That's fine. So this becomes 3 by 2 by raised to the power 1 by 3 a raised to the power 1 by 3. Variables are separable. So let's separate the variables. A raised to the power 1 by 3, 2a raised to the power 1 by 3 dx equals 3y raised to the power 1 by 3. So this becomes 2a raised to the power 1 by 3 into a. आप चाहें तो a को यहाँ पर लिख सकते हैं, कोई विशेष नहीं पड़ रहा है अपने को. 3 अभी ये क्या हो जाएगा y raised to the power 1 by 3. So 1 by 3 इंटीग्रेट कर रहे हैं 4 by 3 divided by 4 by 3. So and plus हम अगर मैं इसको भी यहाँ पर लिख लूँ तो भी कोई इश्यू नहीं है. And let's say I write this as x plus c. So ultimately I have 3 ऊपर जाएगा 9 by 8 a raised to the power 1 by 3 by raised to the power fair. I guess somewhere what is happening. Let me check the data first. Just wait a minute. क्योंकि y यहाँ पर है. Oh, 4. This will become minus stuff. I'm sorry. क्योंकि ये इसके साथ में आएगा ना. ये मैं कह रहा था कि वो मैच नहीं कर रहा है. I'm sorry for that. Actually, this will become 2 by 3 a raised to the power 1 by 3 1 upon y raised to the power 1 by 3 equals dx. So if I integrate this 2 raised to the power 1 by 3 y raised to the power minus 1 by 3 plus 1 क्या हो जाएगा y raised to the power 2 by 3 divided by 2 by 3. That is x plus some integration constant c. चलिए 2 से 2 गया, 3 से 3 गया, अपने को मिल गया a raised to the power 1 by 3 y raised to the power 2 by 3 equals to x plus c. Right? चलिए. So you can leave here as the general solution. This is the required general solution of 1. But what I told you yesterday, when you try to find the singular solution, what you do? Let's take this as equation 2. अभी क्या करेंगे अपन इसका? राम अनुज शाह, हेलो सर, कहाँ थे बच्चे? हाँ, कहाँ गुम हो गए थे तुम? शुभ्रांशु, please try after this. Yesterday I told you how to find the general singular solution. Please try this. If you are not able to do let me know. शुभ्रांशु, शिवू, आज सबके सब कहाँ हैं? चले. Some persons who may be new to this lecture only, they may think कि सर क्या टाइम पास कर रहा है करके. Dear, I told you this is an offline lecture, okay? In the mode of online. So I always give problem, we discuss the problems, we chart out the things. सर बहुत जरूरी काम हो गया था, नहीं तो डेली अटेंड करें लाइव बैच भी हम बाद में कर लेते हैं। ओके रामानुज, कोई दिक्कत नहीं है, पढ़ना जरूरी है, कैसे भी पढ़ो, ठीक है। चलिए मेरे बच्चे, अब हम जाते हैं स्टेप 2 पर। मैं उसको यहाँ लिखता हूँ। ओके शुभ्रांशु, चलो, आई होप यू हैव ट्राइड। देखेंगे, yesterday I told you you can make this differential equation. What you have two ways: making 2 in quadratic as quadratic in C, or taking 2 as phi equals to 0 and diver phi over diver C equals to 0, then remove C. I am a bit slow here. It is like intention. देखिएगा, if you do the cube, then this 1/3 power will be gone, right? So cubing 2 क्या मिल जाएगा बच्चे मुझे? A raised to the power 1 हो जाएगा, by square will be there, and that will become x plus c का whole cube, right? So this I can write as x plus c का whole cube minus a by square equals to 0. This I will call it as phi of x by c as 0. Let's say this is 3. Now what I'll do, diver phi over diver c. So please differentiate this. Diver phi over diver c को 0 put करेंगे. So this implies we will have 3 into this 0 equals to 0. This implies x plus c equals to 0. This implies x equals to minus c. Please do notice here, I will mark star. Now using x equals to minus c in 2. 2 कहाँ है आपके पास? ठीक है, we get, is it visible? Yes, we get y equals to 0. ठीक है, we get y equals to 0. Now please notice, yesterday I told you very clearly that this 4 is the C discriminant relation for 1. 4 is not the general singular solution. 4 is a C discriminant for the differential equation that's given. Now, if 4 satisfies 1, then 4 will be a singular solution of 1. Please notice if, अब देखिएगा, since y equals to 0, so y dash क्या हो जाएगा? 0 means p. On putting in 1, satisfied? Yes. So बोलेंगे y equals to 0 is a singular solution of 1. That is the answer 2. That is the answer 1. Because the question asked you to find general solution and singular solution as well. Shubhranshu, is it clear now? Shubhakaran, is it clear? Because yesterday we couldn't do many problems. Note कर लिया? Is it noted? आज शिबू कहाँ गए थे? दिवाइनी, शिबू, प्रियंका. चलिए. I guess the process of finding general solution and single solution is now clear. Let's take some more questions and try those questions. ठीक है? अभी हम उठाते हैं कुछ क्वेश्चंस where they ask solve okay, that is the okay, fair, write the question, very good question, very nice question, let's take that. चलिए, the question is, देखते हैं how many of you will do this question, that is for you, okay, I will solve later. Question 2 that they asked in CSE 2019. चलिए, obtain the singular solution, obtain the singular solution of the differential equation dy over dx का whole square into y upon x का whole square cot square alpha minus 2 into dy over dx into y by x plus y by x का whole square cosec square alpha equals to 1. Please try everyone. Okay ना मनोज, ठीक है, कोई दिक्कत नहीं. चलिए, please try this question. And let's see how many of you will be able to solve this. Try, I am waiting for you. At least tell me the general solution. हो जाएगा तो यस और नो से रिप्लाई करेंगे. Is that done? Please do let me know. अरे यस नो तो बोल दो. क्या यार, इतना ड्राई क्लास कैसे चलेगा भाई? चलिए, एनीवेज मान लेते हैं अब आपको, ठीक है. देखिए, दिस क्वेश्चन ऑलरेडी वी हैव डन इन द प्रीवियस लेक्चर. कहां पर किया था? इक्वेशंस सॉल्वेबल फॉर p, and not only we had done that, I also emphasized very much over that how to tackle such questions in this chapter, and I told you over, I give many minutes over this. देखिएगा क्या लिखा है ये, p square into y square by x square cot square alpha, right, minus 2p by x plus y square by x square cosec square alpha equals to 1. This can be written as p square by square cos square alpha minus 2p x by x square डिनोमिनेटर में, राइट, 2p x by ये साइन अल्फा यहां पर जाएगा, साइन स्क्वायर अल्फा प्लस बाई स्क्वायर साइन स्क्वायर अल्फा इनटू cosec स्क्वायर अल्फा 1, and that goes to sin स्क्वायर अल्फा, राइट. अब बोलो ये किया कि नहीं हमने? Already done, right? So check from the प्रीवियस क्लास, कौन सा वाला क्लास, ठीक है। इसका हमने जनरल सॉल्यूशन में सीधा लिख रहा हूं डायरेक्टली फ्रॉम द प्रीवियस। जनरल solution is, the general solution was plus minus x square tan square alpha minus y square equals c minus x sec alpha. On squaring both sides क्या मिल जाएगा, x square tan square alpha minus y square equals c square plus x square sec square alpha minus 2x sec alpha into c. This implies we have c square minus 2x sec alpha into c plus x square sec square alpha minus x square tan square alpha plus का y square. This comes out as c square minus 2x sec alpha into c. Sec square alpha minus tan square alpha, ये माइनस है यहाँ पर, ठीक है, ध्यान रखिएगा। sec square alpha क्या बन जाएगा अभी बताइए, z1, ठीक है, plus y square. This is what my dear quadratic in C, right? What I told you yesterday, my dear. This is quadratic in C. तो इसका सिंगुलर सॉल्यूशन कैसे लिख सकते हैं? So C discriminant relation is given by, since quadratic है तो हम Dever 5 वाले मेथड में we can try for the Dever 5 method as well, that is also open. But if it is quadratic in C, so we will just apply this wala part, b square minus 4ac equals to 0. B is the c ka coefficient, so that is 4x square sec square alpha minus 4 into a ka c square ka coefficient 1, and that is x square plus y square equals to 0. Ultimately what you have, my dear, 4x square yahan se ban jayega sec square alpha minus 1, ठीक है। इसमें तो मैंने 4x स्क्वायर sec स्क्वायर अल्फा माइनस 1 ले लिया, माइनस 4y स्क्वायर, सो x स्क्वायर tan स्क्वायर अल्फा माइनस y स्क्वायर, so that goes to y square, so y equals plus minus x tan alpha. Can I say this is a singular solution? Tell me, dear. No, dear, we have to check. Now check if y equals to x tan alpha satisfies 1, y equals to minus x tan alpha satisfies 1, and whichever will satisfy, that will become the singular solution for this differential equation. Is that clear or not? Let's say y equals to x tan alpha satisfies 1, then y equals to x tan alpha is a singular solution of 1. Please make it confirm, are you able to do singular solutions and general solutions as well for the UPSC part? Is there any doubt? Then please do let me know. Otherwise, I'll move for the next topic now. The class is okay or not? Why you people are not responding? Shubhranshu? Please note down. And this is very good question. I told you earlier also, again I am saying this is very important question. So what is my suggestion now for you? Please do solve all questions of solvable for p, solvable for y, solvable for x, and Clairaut's form, and find general solutions. Reach till here. After this, if they ask, I don't know what is happening. Clear, Sarji, Ramanuj. Okay, fair. Reply नहीं आ रहा है तो मुझे लग रहा था कुछ प्रॉब्लम है. चले. Okay, dears. So the first choice is getting the general solution. No matter they asked general solution or not. After finding general solution, you have two ways to go. What are those two ways? Number one, eliminating C using phi equals to 0 and dever phi over dever C equals to 0. Number second method, if general solution gives you a quadratic equation in C, then you can follow this method. How these two methods gives you the same result, that I discussed yesterday very well in the form of theory of this method, finding singular solutions. Okay. One thing extra I would like to tell you here. After this, I will start. देखिएगा. Please notice this. Not asked in exam, but okay. Let's have a general idea over that. मैं एक हिंट लिखूंगा, इससे सारी चीज क्लियर हो जाएगी. लिखिएगा, आउट ऑफ C discriminant, those factors which does not satisfy given differential equation means not singular solution. ठीक है? Those will constitute extraneous loci. ठीक है? इसके बाद इसमें tech locus and all, node cusp. No need to do R&D over this. Just have a general idea for extraneous loci. ठीक है? Although which notes I will provide you, in that I will add some one or two example. You have to just go through. I suppose that yesterday I took an example where I had two factors. Please notice here. For example, if C discriminant relation gives y into y minus 3 equals to 0. Okay? If y equals to 0 does not satisfy differential equation, then y equals to 0 will constitute extraneous loci. Okay? And what will be the power of this? Based on the powers, these node, cusp and locus will be described. Okay? So when after the civil services exam, forest services comes into the picture, then we can discuss much over that. This example one in the previous class. First persons who were present yesterday, they would know this. I had find two factors here. Y equals to 0 did not satisfy the given differential equation. So if in the C discriminant or P discriminant, if suppose that 5 factors are there, only 2 of those satisfy differential equation, then those 2 will come under the category of singular solution, and remaining 3 factors will come under for this extraneous loci. Is that clear to you all? भरोसा दिलाइए. Singular solution, general solution. If any doubt, then do let me know. नहीं तो अब हम मूव करेंगे नए टॉपिक की ओर. I guess you have noted down. So chapter 1 is over now. Yes, I will give some assignments, problems from your side if comes. Then I will take extra session for chapter 1. That will be our doubt taking session. For me, my side, I have completed the chapter 1. Chapter 1 is differential equations of first order. First segment of order 1, degree 1. Second segment of order 1, but not of degree 1. Now I'm going to start a fresh topic. Should I start? Ramanuj, no doubt. Okay, Ramanuj. चलिए आगे बढ़ते हैं. Chapter 2. And that is higher order differential equations. Please listen my words carefully and don't sit with any pre-assumption, okay? Just see what picture I want to draw in your mind, because here we may have thousands of things to study, but we must summarize those. We must have a comprehensive understanding of those. So I am gonna do that for you. Chale. So when I talk about higher order differential equations, what are those? Let's say I have a differential equation a naught x, some constant, some coefficient. I will say only one thing. I will start from the zero level. If you are comfortable, you know how to find CF and PI, then I will suggest you attend the lecture. You will come to know some very beautiful things today. I'm pretty sure for that. Chale. A1x dn minus 1 by over dxn minus 1 plus a2x dn minus 2 dxn minus 2 plus an minus 1x dy over dx plus anx by equals to some function of x, where x is the independent variable given to us. Let us give this as equation 1. Here, when I say higher order differential equation, it means n is greater than 1, or you can say n greater or equal to 2. If n becomes 1, this differential equation reduces to the first order differential equation. And first order we have already dealt. So when I talk about higher order, means your order may be 2, 3, 4, anything, right? Up to any finite order. Fair? Chale. Case 1. If a naught x, a1x, anx all are constants, then one is a differential equation with constant coefficients. Okay. Case 2. If not case 1, right, then it is differential equation with variable coefficients, right? Both of these cases in our syllabus, we have to study both of the cases. So in case of variable coefficients, this is a very selective category. Here we have two cases. Number first is reducible to constant coefficients. That means case 1 means case 2 के अंदर we will have a restricted case and that will be Cauchy-Euler's differential equations. Is it visible? Fair. And this is very standard kind of, like suppose that the differential equation a naught x power n dn by over dxn. Fair here. A1, sorry, this is constant. Okay, let's say that is alpha naught. That is alpha 1 x power n minus 1 dn minus 1 by over dxn minus 1 plus alpha n minus 1 x into dy over dx plus alpha n by equals to some function of x. If you observe this differential equation, this is a very special kind of differential equation where x ka power is same as the order of the derivative, where x ka power same as the order of derivative. So such differential equations will come into the Cauchy-Euler differential equation, and Cauchy-Euler differential equation basically वो दिखते तो हैं, those are looking like with variable coefficient, but those will be ultimately reduced to constant coefficients. Okay dear, so that is the part 1 in the variable coefficient. Part 2 in the variable coefficient is d2y over dx square plus some function of x dy over dx plus some function of x into y equals rx. Fair, my dear? Means here this p of x may be any function, not the category like this. ठीक है? So यहाँ पर we will study method of variation of parameters, change of independent variables, right? Normal form. Okay dear, ये हम यहाँ पर methods पढ़ेंगे. ठीक है? So the overall picture is यहाँ पर we will learn about CF and PI, that is complementary function and particular integral. So if I draw a mind map for me, what I have to do in the higher order differential equation, that is solving a higher order differential equation with constant coefficient, with variable coefficient. With variable coefficients में two cases. Number one is Cauchy-Euler, other is the general form. Here we will not have more than order 2. Only in our syllabus is up to order 2 of this form. Fair, my dear? चलिए. The most important thing which I want to convey here is, ध्यान से सुनेंगे इस चीज को. Okay, we may think कि this is the only thing to study, but before that, we will have some small topics that I will call it as introduction to higher order differential equations. ठीक है बच्चे? Although we may think only solving such differential equations is the task for us, but it is not so. We must know linear combination of solutions. We must know linear dependence and independence of solutions. We must know Wronskian of solutions. We must know existence and uniqueness of solutions of an initial value problem. Fair? Then we must learn what is general solution and why CF is always in this form. You getting my point? So you may think कि sir will come and he will start from finding CF and PI. No, my dear. My way of teaching for this module, this particular chapter will be, first I will be telling you this introduction part, because without this you will be just a like na Rattamar Zindabad, just mug up kind of things. But they may ask questions from this segment as well. So abhi what I'm gonna do, I will start from the introduction, will come to this, then will come to this. Okay dears, so our lecture, प्रीतम कुमार, Wronskian से एक से दो क्वेश्चन आया है प्रीतम. Okay प्रीतम, that's good. Wronskian से आया है or it is coming from the combination or all, you don't worry my dear. I will give you a lecture which will comprise of everything for this syllabus of CAC as well for a services. Okay? So just follow, just be blank. I have like combined, comprehend everything at one place. Okay? Please note down this. अपने notes को proper रखिए. केवल lecture देखने से काम नहीं चलेगा. Everyone I am suggesting, please prepare class notes chapter 1. These are the segments. अब हमारा जो target होगा, this will be the first, this will be the second, this will be the third, and this will be the final fourth. Ultimately, we will have 4 segments here: lecture 1, lecture 2, lecture 3, lecture 4. Clear? चलिए हटा दूं. अब करते हैं, अब देखते हैं आपने क्या क्या पढ़ा है. Let's see what you have studied. And I am pretty sure many of you don't know what is the definition of CF. If you know, yes or no, why CF is written like this? Please tell me the answer. Please tell me the answer why CF is written like this, or why CF you write C1 e raised to the power m1x, e raised to the power m2x, and so on. Can you tell me the reason behind that? Anyone? Yes, anyone? No. चलिए कोई बात नहीं, आगे बढ़ते हैं. Write a heading please. हेडिंग डालेंगे segment 1, that is introduction. ठीक है? And the first heading is existence and uniqueness theorem. बार बार इतना लंबा चौड़ा नहीं लिखेंगे. We will not write again and again. That I will call EUT. Okay dear? चलिए. What is the EUT that we must know? ध्यान से देखेंगे, मैं बहुत ही पेशेंस के साथ, I will move on with patience, no matter you have time or not. Okay? So whenever you have some theorem, ठीक है, you will have a statement of the theorem. What is that statement? Let's consider a differential equation a naught x by double dash. Double dash means d2y over dx square. Okay सुधाकरण? So अभी हम ये नहीं लिखेंगे, just double dash. Triple dash means 3 times. Ramanuj, if we put c1y1 in the equation and we get c1 0. No, no Ramanuj. It is not so. By dash means dy over dx plus a2x by equals to some Rx where A naught x is non-zero. Can anyone tell me why A naught x is non-zero here taken? Anyone? Why A naught x is non-zero taken? In homogeneous equation. देखिए बच्चे, if A naught x becomes zero, this will be reduced to first order. जबकि हम किसके लिए पढ़ रहे हैं? हायर ऑर्डर के लिए. किसके लिए? हायर ऑर्डर के लिए. We are studying, Sudhakaran. I am repeating the things, okay? Loss of order. Yes, Ramanuj. Fine. Sudhakaran, I am repeating the things. Don't think it is always in Hindi, okay? Let us consider a differential equation. A naught x by double dash plus a1x by dash. This is a differential equation. Fair? A naught x is non-zero. Otherwise, this will be reduced to first order. And that we are not considering. Okay? Chaliye. Here, a naught x, a1x, a2x, and rx all are continuous. Please underline करेंगे इसको. Continuous functions. ठीक है? Now, if there exists, और इसको हटा देते हैं, बाद में देखेंगे. Now, if it is given, ध्यान से देखेंगे, that y at x naught is some c0, y dash at x naught is c1, y double dash is dash तक second order है ना, fair. That is c1, where x naught is an initial point for the given domain. Then the given IVP has, IVP means initial value problem, because this is a differential equation given with some initial condition. So this with this will be known as initial value problem. Then given IVP has unique solution. Fair? That is the existence and uniqueness theorem. What it says here, if this is a differential equation, please focus here. Continuity is assured. If order is 2, then such two conditions are given. Then this problem will have unique solution. Fair? There is a corollary of this statement as well. Corollary is that if देखिएगा Rx equals to 0 in above differential equation and C1 equals to 0, C0 is 0 and C1 is 0, then given IVP has only the solution yx equals to 0, right? This is very beautiful. और you can say अगर आपका डोमेन यहाँ पर x a b में था, so you can say yx will be identically 0. This is identically 0. Note down please. Yx is identically 0, or you can say, or yx is 0 for all x in the given domain. Now I am done for this EUT. What it says, if you have a differential equation like this with these two conditions, then this will have a unique solution. Moreover, if this becomes homogeneous, means RHS is 0, then and also the conditions are given that y at x naught is 0, y dash at x naught is 0, then this problem will have only solution as yx equals to 0. Why? Unique solution. Why so? प्लीज रिप्लाई करेंगे प्लीज, ऐसा क्यों हो रहा है, ये बाई एक्स आइडेंटिकली जीरो क्यों है? एनीवन? चलिए देखिएगा, इसको डाल देता हूं मैं नंबर 1, इसको डाल देता हूं नंबर 2, ठीक है, फॉर दिस कंडीशन एज नंबर 3। देखिएगा, सिंस yx equals to 0 satisfies a naught x plus a1x by dash plus a2x by equals to 0 as well as y at x naught is equal to 0 by dash at x equals to 0. So yx equals to 0 is a solution of this IBP. But since a naught x, a1x, a2x all are continuous, ठीक है, so by EUT the given IBP has unique solution. On combining 4 and 5, what I can say, yx equals to 0 is the only solution of IBP 4. Please check it out. Yx equals to 0 means yx is identically 0 or yx is 0 for all values of x. EUT is clear or not? The statement अभी नहीं हुआ होगा, तो let me give you some question, then we will see कि how it will be. चलिए, persons who were thinking कि sir why you are teaching this, for them I am giving you a problem to think. चलिए अच्छा मुझे बताना, the differential equation, yeah, the initial value problem, e raised to the power x square d2y over dx square plus 2x cube cos y dy over dx plus x by equals to e raised to the power x into y with y at 0 equals, मान लो यहाँ पर जो x है वो आपका -1 से 1 के बीच में, the IBP has unique solution. Please tell me it is true or false. This is a challenge for you. No matter how many times you found CF, now tell me, if you didn't study EUT, please tell me the answer of this question. And now you will understand the importance why I am so much focused on these things. Tell me the answer of this question. It is true or false? Please reply. False. ओके रामानुजा, चलिए मान लेते हैं false. बाकी लोग बोलेंगे, rest of the persons. Ramanuja, you have found CF many times, but today I taught you the definition of EUT. चलिए apply कीजिए. What is a naught x here? E raised to the power x square, exponential function. Dabagul क्या बोल रहा है, डब्बा खुल a1x is 2x cube cos y, a2x is x by, rx is e raised to the power. All are continuous functions or not? विश्वास दिलाइए. All are continuous functions. Also, a naught x is not equals to 0 because exponential function gives 0 only at minus infinity. But my x is minus 1 and 1. So a naught x, because this is e raised to the power x square, this cannot be 0 for x belonging to minus 1 to 1. Also, two conditions are given. So by EUT, given IVP has unique solution, because what EUT says, if these all are continuous, two conditions are given like this, then this problem will have unique solution. Ramanuj, so this statement is true, my dear, not false. अब निकालो CF, तब जाने. जरा सा भी कोशिश किया ना इसको सॉल्व करने का. If you try to solve this, इस जन्म में तो नहीं होगा, अगले में हो जाए तो पता नहीं. I am saying solving the differential equation is one game, observing the differential equation का solution is another game. And how you can observe the solution of the differential equation? By the EUT that I have discussed here. So no need to solve this IVP to get the uniqueness. Only you observe these two conditions, whether these all are continuous and these two conditions are given or not, this will have a unique solution. That's it. I guess. Ramanuj, I take whole domain R. Okay, बच्चे. लिखा तो था मैंने बच्चे रामानुज, फिर पूरा क्यों ले लिया? चलिए, तो आई गेस EUT का इंपॉर्टेंस विल बी क्लियर टू यू. ठीक है, बट राइट अ नोट प्लीज, राइट अ नोट प्लीज, एंड स्टार मार्क कर लेंगे. कंडीशंस अप्लाई. EUT is a sufficient condition but not necessary. And please do remember this. This implies means if EUT is not Ramanuj, this is your answer. आपने जो फॉल्स बोला था वो भी सही नहीं था. ठीक है बच्चे? क्यों नहीं था? If EUT is not satisfied, then we cannot say given IVP does not have unique solution. Please do remember. Okay, Ramanus? If EUT fails, for example, if a naught x 0 हो जाए और discontinuity आ जाए, if there is discontinuity, then we need to solve the given IVP. Then only we can tell the nature of solution. Okay, Ramanuj, is it clear now? Chale. Okay, no matter you have seen the domain or not, if you think na a naught x becomes 0, Ramanuj ध्यान देना, still you cannot say कि this does not have unique solution. In that case, you need to solve the differential equation, because EUT is only sufficient, not necessary. Please do remember this. Please note down till here. मैं बाकी साफ कर देता हूँ, है ना? So I guess you will have a clarity in your mind why I taught you the EUP. Many may skip this, no issues, but I found this useful, so I told you. Please note down this, then I will start some fresh subtopic. Please note down. Is it done? चलिए आगे बढ़ते हैं. Write a heading, please. Linear homogeneous differential equations. Write a heading, please. New heading for us. Linear homogeneous differential equations. For higher order, ठीक है, देखिएगा. For example, if you have a differential equation like A0 nth order derivative, Sudhakaran, I am more worried for you. This is nth order derivative. When you write n in bracket, it is in sort of dn by over dxn. So suppose that I have a differential equation please notice from here you will have questions. Let's say this is the differential equation for us. Okay. So this you can write as dn upon dxn a1x dn minus 1 dxn minus 1 plus an minus 1 d over dx plus an the whole outside as y, means y is operated here, 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 the same you want. That is equals to f of x. Now I represent this whole expression as some differentiation operator capital L. Please do focus here. I represent this expression as capital L and I write this as Ly equals to f of x. Fair? Now, if f of x is 0, then Ly equals to 0 is said to be a linear homogeneous differential equation. ठीक है? If f of x is non-zero, so Ly equals to f of x is known as non-homogeneous differential equation. Why I have given you this definition? This is just a differentiation operator because now onwards, whenever I will have the expression like this or like this, I will represent the expression like this in this form. Then please don't cry, this is what it is. Then L will represent such expression, okay? Now onward, I will be taking L. So you will understand what I mean by L of by. Okay, dears? Chaliye. Please note down, I will change the marker first. And why I talked to you for this linear combinations and linear differential equations? Write the question, please. लिखेगा. Let if by 1x comma by 2x are any two solutions of, please write the question, of a naught x by double dash plus a1 x by dash plus a2 x by equals to 0. Here I have taken a naught x as non-zero. Then any linear combination of by 1x and by 2x is also a solution of differential equation 1. Prove or disprove. That is the question for us. Please try. Please tell me. अच्छा, yes or no, true or false बता दो. This is true or false? हाँ? Anyone? अरे reply my बच्चे. चलिए, कोई बात नहीं, मैं करता हूं. आप नहीं करेंगे तो मैं कर दूंगा, और क्या है. ट्रू, फेयर. चलिए देखिए हाउ. सिंस a naught x by double dash plus a1 x by plus a2 x by equals to 0 can be written as Ly equals to 0. Linear homogeneous. Linear. अब don't ask sir what is linear. Already discussed in the previous lecture 1. ठीक है? Principle of superposition. Okay रामानुज. चलिए. Let's say this is 1. Since by 1x is a solution of 1, so it must satisfy, right? Since by 2x is a solution of 1, so it must satisfy. Now let y of x equals to c1 by 1x plus c2 by 2x. Check if yx satisfies 1. अगर 1 को satisfy करना है तो Ly means L of c1 by 1 plus c2 by 2, it must be 0. So since L is a differentiation operator, so this can be written as L of c1 by 1 plus L of c2 by 2, because d upon dx of 2x plus x square. How you can write? D upon dx of 2x plus d upon dx of 2x square. What is the problem there? No. C1 is a constant, so this can be taken outside. C2 is a constant, so this can be taken outside. L by 1 is what? 0. L by 2 is what? 0. This comes out as 0. So what is our answer? Yes. Fair? So what we can say? Therefore, C1 by 1 plus C2 by 2 is also a solution of 1, where C1 and C2 are arbitrary. So any linear combination of by 1 and by 2 is again a solution of 1. Please do remember this. And how you will remember this, my dear? Please remember this statement. आप चाहें तो लिख लीजिए कॉपी में. देखिए, the linear combination of solutions of a linear homogeneous differential equation is again a solution of that differential equation. I guess it will be clear. Please note down. लिख देंगे इसको and write a note please. नोट क्या एग्जाम पॉइंट, इट इज ट्रू फॉर एनी ऑर्डर ग्रेटर और इक्वल टू 2 मीन्स, ध्यान से सुनिए, if by 1 by 2 by 3 are solution of third order linear homogeneous differential equation, then linear combination is again a solution. If by 1 by 2 by n, क्या बोलेंगे इसको, एग्जाम पॉइंट यहां पर लिख सकता हूं, नहीं दिखेगा, if by 1 by 2 by n are solutions, then c1 by 1 plus c2 by 2 plus cn by n is again a solution of a linear homogeneous differential equation of order. I guess it is clear. Please note down and do remember, because if you don't remember this, you don't understand the basics of this differential equation. Please note down everything. And persons who feel boring in this lecture, they may quit the class and they may attend the class from tomorrow. वहां पर I will calculate simply CFPI, कोई इशू नहीं, ठीक है. चलिए, but I have an interesting problem out of this point. लीनियर कॉम्बिनेशन वाले से एक इंटरेस्टिंग पॉइंट प्रॉब्लम है हमारे पास. लेट्स डू दैट. राइट अ क्वेश्चन प्लीज एंड प्लीज डू रिप्लाई. If by 1 by 2 by 3 are solutions of Ly equals to f of x, where f of x is non-zero, then 2 by 1 minus 3 by 2 plus 2 by 3 is also a solution of Ly equals to f of x. Prove or disprove? Ramanuj Jha. Now reply. Tell me, it is true or false? Anyone? And be ready for such questions in the coming years. Okay? आसान है, बहुत आसान है. Please reply. अरे यस और नो तो बोलो. चलिए. Solution. Let's think. If by 1 comma by 2 dot dot by n are solutions of Ly equals to f of x, इसलिए on satisfying क्या होगा, L by 1 f of x, L by 2 क्या होगा, f of x, L by n क्या होगा, f of x, right? Now what is L of c1 by 1 plus c2 by 2 plus cn by n? That will become what I told you just now. This is a differentiation operator, so it will be distributive over here. So this will become L of c1 by 1 plus L of c2 by 2 plus L of cn by n. This will become c1 is just a constant, ठीक है, c2 is just a constant, cn is just a constant, right? C1. L by 1 is what? F of x plus C2. L by 2 is what? F of x plus Cn. L by n is what? F of x. Right, my dear? So this will become C1 plus C2 plus Cn. F of x मैंने कॉमन ले लिया. Now the real picture starts. Okay, Ramanus, I got your point. देखिएगा, this is equal to f of x only when C1 plus C2 plus Cn equals to 1. Otherwise, not equals to f of x. Otherwise, किसके otherwise? इसके. Right? So what you have shown here, if please इसको देखिएगा, very interesting. If by 1 by 2 by 3 are solutions of Ly equals to f of x, then C1 by 1 plus C2 by 2 plus Cn by n means this is what? This is linear combination of by 1 by 2 by n. Why it is linear? Because by 1 by 2 by n the power is 1. So this is linear combination of by 1 by 2 by n. This will satisfy Ly equals to f of x only when C1 plus C2 plus Cn equals to 1. Otherwise, nahi. So what you will remember? Exam point. C1 by 1 plus C2 by 2 plus Cn by n is also a solution of Ly equals to f of x if C1 plus Ca2 plus Cn equals to 1, otherwise नहीं. तो अब आप देखिए इसका आंसर. क्या है C1 का वैल्यू 2, C2 का वैल्यू क्या है -3, C3 is 2, C1 plus C2 plus C3 is what? 2 minus 3 plus 2 equals to 1. So 2 by 1 minus 3 by 2 plus 3 by 3 is also a solution of Ly equals to f of x. So now listen my words. If they ask such question in UPSC, then you will have to start from here. You will have to write these many lines. Then only you will reply like this. So this is the step 1 and this is the step 2 of the question, because UPSC asks you questions in subjective nature, not the objective. Fair? If it is objective question, then it is easy, just observe, say yes or no. But UPSC will ask you subjective, so it is your duty to write like this, then apply this to get your answer. That's it. Is that clear now? So for the introduction part, we have 4 important segments. Number 1 is the EUT and linear combination. That is done now. Abhi we will take a 10 minutes break. ठीक है? Please note down this. पहले इसको नोट कीजिए. Is that noted? चलिए. So अभी we have a break. ठीक है? टाइम क्या हो रहा है? 10:20 PM to 10:30 PM. Class will start. ठीक है? चलिए. Yes, Ramanus, CSIR asked these questions. So see, if CSIR asked very like few years back, now UPSC may frame questions subjective nature. Okay, so it is our duty to learn this. Ramanuja, we cannot expect कि CSIR ask or this not. I only know this is the concept, and concept we cannot ignore. Okay, Ramanus. So don't think in which exam they ask. Only focus. This is a concept which I need to learn. Okay. Okay, Ramanaj. Okay, we'll meet at this. रामानुज शाह, क्या डाउट है तुम्हारा? प्लीज कैन यू रिपीट योर डाउट प्लीज? Sure. So let's start the class after a break. Everyone came? Chale. So now we will start a very nice topic. Yeah? That is very important. For that we are here. That you can say, write a heading please. Wronskian of a set of functions. I suggest you guys not to confuse between Wronskian and Jacobians. Okay? Wronskian and Jacobians. Functions of one variable. Okay? Jacobians is in form of partial differentiation as functions of more than one variable and different functions. Okay? So don't confuse. When we will come in the differential calculus, we will learn about that as well. Okay, yes. So write the definition please, and don't forget the definition. लिखिएगा. Let सीधा मैं लिख देता हूँ. Wronskian of, let's say I have some functions f1x, f2x, fnx is given by the determinant value as. So when I say Wronskian of f1x, f2x, fnx, this you can also represent w of x. Okay, bache? Not an issue at all. This is computed by f1 determinant value of f1x, f2x, fnx, f1 dash x, f2 dash x, fn dash x. Fair? Sorry, एक और लाइन लिख देता हूँ, फिर आपको समझ आएगा. f1 double dash. What, Sudhakaran? What is double dash here, my dear? Derivative 2 times, right? and so on, and the last row will be n minus 1th order derivative if you have n functions, right? For example, don't confuse. For example, let's say you have taken two functions, Wronskian of e raised to the power sin x. This is your f1x, this is your f2x. So this will be the determinant value of f1x, f2x. ठीक है बच्चे? f1 dash e raised to power x का differentiation e raised to the power x, sin x का differentiation cos x. What is the determinant? E raised to the power cos x minus e raised to the power sin x. That comes out as e raised to the power cos x minus sin x. So if someone asks what is the Wronskian of these two functions, that will be this. Now the definition is clear. Let's say someone asks you what is the Wronskian of 1x x square. So it will be 1x x square 0 1 2x 0 0 2. Double derivative, right? This will come out as 2 into 2x square minus x square, that is x square. That is the Wronskian of these three functions. Okay, so the Wronskian definition is clear to you? Fair. So why we are studying Wronskian here? What is my question? Why we are studying Wronskian? What is the need of that? So my answer is to check linear dependence and independence of solutions of a differential equation. Okay, dear? For example, let's say some says solutions by 1 equals to sin x and by 2 equals cos x are two linearly independent. लिख लेंगे तो ख्याल आएगा. Linearly independent solutions of d2y over dx square plus y equals to 0. Please tell me true or false. Prove or disprove. Now then you will realize now why I am teaching you Wronskian. So step 1. First of all, we need to check whether those are solutions or not. Since y1 is sin x, so y1 dash क्या हो जाएगा? Cos x. y1 double dash minus sin x satisfies 1. So y1 equals to sin x is a solution of 1. Okay. Similarly, y2 equals to cos x is also a solution of 1. Step 2. Now I wish to have whether those are linearly dependent or independent. Here we have two instruments to check. Please notice here, to check y1 and y2 are aligned. So we have two ways. Way 1, that is linear algebra. When we will be studying, we will be talking about definition of linear dependence, linear algebra. But here, by computing Wronskian. Okay, that is the way 2. Sure. So how? देखिएगा. If W of F1, F2, Fn is 0, then F1, F2 dot Fn are linearly independent. And if W is non-zero, sorry, if zero, then it is linearly dependent, and if it is non-zero, then linearly independent. Okay, my dear. So that is an exam point for you. Please do remember this exam point. Okay, dears. Am I audible to you, everyone? Please make it confirm. Is this audible? Okay, fine. So here, step 2 के लिए what you will do? I will apply the way 2. And what is way 2? I will compute Wronskian of sin x and cos x. That will be what? Sin x, cos x, sin x का differentiation cos x, that is minus sin x. It will minus sin square x minus cos square x, that is minus 1, which is non-zero. So हम क्या बोल देंगे? Sin x, cos x are linearly independent. So this statement comes out as. Did you get the point? Why I told you Wronskian here? Am I audible? Fair. Chale. So for the Wronskian part, please do remember dependence and independence. Okay? Chale. Here we have one more definition for Wronskian. I am coming on that. But before that, I would like to tell you, checking the dependence and independence is a very important topic, because to find CF, you can write like this. To find a complementary function, we need Li solutions. Okay, my dear? So in case of, as I asked you question now, why CF is written like this. So when I will be teaching you CF in the next lecture, then I will be using whether those are Li or LD. For Li or LD, I will be using this way too. Then you please don't cry. These are what you are doing. Okay? Is it noted? Everyone? Please reply. Have you noted the things? Sure. Now I'm gonna tell you one more important point here about Wronskian, because that is very crucial for us. Okay, dears. Write down a point, please. लिखिएगा. Let if by 1 and by 2 are two solutions of the differential equation okay, then the Wronskian of, very important, I am saying for your CSE as well as for establishment. If by 1 and by 2 are any two solutions of this differential equation, then the Wronskian of by 1 and by 2 is either identically zero or never zero. Fair? Whenever we talk about Wronskian of solutions of a differential equation, then Wronskian is either identically zero or never zero. So what I told you here, way 2, कि if Wronskian is 0, then LD and Wronskian is non-zero, then Li. Means for any solutions, Wronskian cannot take value 0 as well as non-zero. या तो 0 होगा, either it is 0 or non-zero. If it is 0, then Li. So it's LD. If it is non-zero, then Li. Okay. So this is a very important exam point for us. For this, what I would like to tell you, I have done the proof of this. Okay, where actually the proof here is not required, but the formula is very important here. तो मुझे बताना ही पड़ेगा. Although जैसे आप क्लास से भाग जाते हैं ना सब लोग, जब मर्जी आए चले आए, जब मर्जी आया चले गए, है ना. अगर मैं ऐसे करने लगा ना तो ये बैच चल गया फिर. और जिसको ये लग रहा है कि हम रिकॉर्डेड से ही देखेंगे तो कल के बाद लाइव क्लास जो होगा ना रिकॉर्डेड ही ऑफ कर देंगे. जिनके सीरियस इश्यूज हैं उन्हीं को रिकॉर्डेड लेक्चर्स दिया जाएगा, बाकी ऑफ हो जाएगा. इफ यू कांट बी पार्ट ऑफ डिसिप्लिन्ड लर्निंग देन आई कांट हेल्प यू. आई एम सॉरी, आई हैव नो प्रॉमिस फॉर यू. आपको जो करना है करिए. रबिश ऐसा लग रहा है जैसे सोते में क्लास चल रहा है. So much quality teaching is going on and you people just like मतलब चल रहा है, कुछ भी करो जो तुम्हारी मर्जी है. ठीक है. I'm write down the like doing the proof. दिमाग में मेरे सेट है. I will try to make you learn. Rest is your doubt. Tomorrow onwards, recording lectures will not be provided for those who can attend the live. Because otherwise इस सबका मतलब क्या है यार. मैं रिकॉर्डेड करके फिर मैं भी रिकॉर्ड कर दूं, आपको दे दूं. चलिए. Since by 1 and by 2 are solutions of the differential equation 1. So y1, please be serious here, be concentrated over this. Such proofs are expected in coming years in your CSE exam. Must satisfy 1. Means a naught x by 1 double dash plus a1 x by 1 dash plus a naught x by 1 must be 0. A naught x by 2 double dash plus a1 x by 2 dash plus a2x by 2 must be 0. That this is the equation 2. Since we know that Wronskian of by 1 and by 2 can be written in the form by 1 by 2 by 1 dash by 2 dash. Fair? This I already told you the definition of Wronskian. So this you can write. I am just skipping this, just writing W equals y1 into y2 dash. Obviously this will be function of x minus y2 into y1 dash. So if I differentiate this with respect to x, what I will have, dw over dx equals, here y1 is a function of x, y2 is a function of x, so we must apply first into second here. So y1 into y2 का differentiation plus y2 dash into y1 का differentiation. This is for this. ठीक है. अब इसमें फर्स्ट सेकंड अप्लाई, y2 y1 का differentiation plus y1 dash वाला फैक्टर into y2 dash. So this dw over dx will come out as, my dear, y1 into y2 double dash. अब देखिए प्लस y2 dash y1 dash minus का y2 dash y1 dash, this will be cancelled out and this will be the remaining factor here. Why I have done like this? From here we are gonna achieve a very fantabulous formula that is called Aggar's formula. With the help of that UPSC asks questions over that. चलिए अभी देखिएगा, this is dw over dx. what I do, I use by 2 double dash ka value from this expression as here, and that will be coming out as, अगर मैं इसको इधर भेज दूंगा by 2 dash को, minus a1x upon a naught x into y2 dash, right, minus a2x upon a naught x by 2 dash, sorry, by 2, minus by 2 into by 1 double dash. By 1 double dash I will get from here. By 1 double dash, इसको RHS में भेज दीजिए, send is in RHS. You will come at as minus a1x upon a naught x into by 1 dash minus a2x upon a naught x into by 1. Fair? What I have done, using 2 in place of by 2 double dash, in place of by 1 double dash. Okay, my dear. What is the reason behind that? Why I am doing like this? The reason is very simple. I want to get an equation involving derivative of W and W itself. See how I will get that? अभी इसको observe कीजिए. This will be minus a1 upon a naught by 1 into by 2 dash minus a1x upon a naught x by 1 into by 2 dash. By 1 by 2, this wala fraction will be cancelled by this, because this will be plus ka, this will be minus ka. So only this factor will be remaining here, and that is minus a1x upon a naught x into by 2 into by 1 dash. What is in the LHS, my dear? That is like this. So minus a1x upon a naught x we can take as outside. This will become by 1 dash minus by 2 dash. This will be coming out as, chale, the fantabulous result is in our hand. What is that? By 1 by 2 dash minus by 2 by 1 dash. That is what? W. So this will, in place of this, I will write W. Please do remember this. This is very important, and Abel's formula it is called. Fair? Please do remember this. Moreover, we can solve dw over dx equals minus a1x upon a naught x into w. कैसे? dy over dx plus px by equals to 0 form, right? So tell me, या फिर इंटीग्रेट भी कर सकते हैं यहां से, dw को यहां पर ले जाएंगे, dw upon w equals minus a1x upon a naught x into dx on integrating. ठीक है, क्या मिल जाएगा? w equals minus a1x upon a naught x, sorry, log w यहां पर, log of w equals minus a1x upon a naught x into x plus some log c, where c is the arbitrary constant. So this will be turned out as w equals, please notice here, w equals c into minus a1 upon a naught into dx. Most important formula in this segment. Log of w is this, w is this. So means we have two things for Wronskian. One is this wala method. If by 1 and by 2 is given to you, then you can find the Wronskian by this. If by 1 and by 2 are not given, some differential equation is given. Please do remember and do note down this. If by 1 and by 2 are not given, but differential equation is given, then by comparing that differential equation, you can get a naught and a1. By using a naught and a1 in this formula, you can find the Wronskian of the solutions of given differential equation. Is that clear or not? Please note down. This is a very fantabulous result we have. Is it done? Abhi, if you want to prove this, either identically zero or never zero, you can prove this from here. Let if W is zero at least 1 point. Case 1, W is zero at least 1 point, or Wx is never zero. Then please give this equation as 2, this as 3. Then from 2 and 3, W dash at x naught 0, W at x naught is 0. Since Wx satisfies 1, इसलिए corollary of EUT gives Wx is identically 0. So what is the case 1 we have done? I am not in hurry. Equation 3 or 4. अच्छा 2 ले रखा है, ठीक है. Satisfies 1. Then corollary, अच्छा from 3 and 4. देखिएगा. What was our target? Our target was कि Wronskian is either identically 0 or never 0. What I have taken here, let us consider if Wronskian is 0 at least 1 point. Then I got from this and this कि W dash becomes 0, W becomes 0. Also we can check कि W satisfies this. W means this. You can observe W dash done, W double dash will satisfy this. So you can say, please listen, Wx क्या कह सकते हैं? Wx is a solution of the differential equation this with the condition W at x naught is 0, W dash at x naught is 0. So by the corollary of EUT, Wx will be identically 0. And what is corollary of EUT? That I have told you. जिसमें आपका interest था नहीं, तो अब मैं कुछ कर नहीं सकता. Either you revise the lecture or leave this. चलिए, हो गया? Thing is, I have been teaching from last over decade. I know where to put efforts. But many of the students, they are not serious. आएंगे जाएंगे. अभी गुस्सा चला दिया आज. बस मैं गुस्सा करता नहीं, लेकिन क्या है? चलो कोई नहीं, आपकी मर्जी है. क्या कह सकते हैं? I will keep on putting my efforts. Rest is your choice. So case 2 क्या होगा? What is the case 2 now? Wx is never 0. क्योंकि if it is 0 at least 1 point, it will become identically 0. The case 2 is Wx is never 0. That only we had to prove. चलिए. Now we will take some questions over this as expected in your UPSC exam. Let's see how those work. चलिए. ABC always be. अच्छा, प्रीतम कुमार पाल. Pritam, you know, I am like a parent, okay? So, I know sometimes scolding is necessary, okay? डांटना जरूरी होता है. Otherwise, I never lose patience, yeah. I know, क्योंकि सबके अपने plans होते हैं. Still, मोहम्मद तौशीफ. I am always cool. Whatever promise I have done, I will fulfill that. बस थोड़ा सा डांट इसलिए देते हैं ताकि you people always be in discipline, okay? चलिए, cool. Thank you, Pritam. Write down the question, please. If by 1 and by 2 are two solutions of d2y over dx square plus dy over dx plus 2 dy over dx minus e raised to the power x square by equals to 0 with y at 0 equals 1, sorry by 1 by 2 है ना, by ऐसे ले लीजिए with Wronskian of by 1 and by 2 at the point 0 is 1. Then find Wronskian of by 1 by 2 at the point 5. Please check it out. Why I was putting so much effort over this. अब लगाओ डिटर्मिनेंट, तब जाने लगाओ डिटर्मिनेंट. चलिए प्रीतम फटाफट. बट मैं रिकॉर्डेड देखता हूं प्रीतम. अच्छा ओके 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 फेयर. Okay, Pritam, I know you talked with me 10 plus 2 tak your maths was there, right? Now you are doing BA program. Am I right or not? So it is allowed for you. Watch from the recorded, okay? I'm not gonna remove anything. वो तो मैं डांट देता हूँ बस ऐसे ही, है ना? कुछ भी नहीं होने वाला है. लाइव लेक्चर्स चल रहे हैं, चलते रहेंगे. Either people attend or not, doesn't matter. ठीक है? चलिए, please hear. अब क्या करेंगे? अभी अभी मैंने आपको बताया था W of by 1 by 2 is what? ठीक है? Compare given differential equation with किसके साथ कंपेयर करें? a0x by double dash plus a1x by dash plus a2x by equals to 0. Fair? चले. We get a0x is क्या होगा? 1. a1 और obviously we need that as non-zero. a1x का value 2. Using in 1. W of by 1 by 2 at the point x will be given by c into a not a1 upon क्या? A upon 1 dx. That becomes c raised to e into minus 2x. Fair? Let's say अपने को क्या given है हमारे बच्चे? W of by 1 by 2 at the point 0 is 1. इसलिए from 2 we have W at 0 is 1 c into e raised to the power 0. This implies c का value is 1. अभी बेसिक के लिए RS अग्रवाल का कैलकुलस कर रहा हूं. Okay Pritam, fine, keep doing. But I will suggest you one thing, as I always say in my lectures, please don't over invest your time. You are in the BA program, so you can do that. Abhi you have time. But if you are just attempting for 24, you are attempting for 25, right? I guess. So you can invest your time over those books. Otherwise, these lectures are enough. I extract those things from 10 plus 2, put here and ask you to revise those. 25, yes, Pritam. चलिए. So अपने को क्या मिल गया? W of by 1 comma by 2 at x equals to c का value you got 1. So that is e raised to the power minus 2x. अब पूछो ना दुनिया जहां का 5 पर क्यों पूछा? 5000 पर पूछो ना. किस पर पूछना है? W at 2 पर पूछना है. पूछो. Right? You got the importance of the formula? Is that clear? Any doubt, my dear students? Please tell me. So, although you know how to compute Wronskian through the determinant, but if differential equation ka format is given, then you need to use this formula because you do not know what is y1 and y2. Some people may try to find कि I will solve this. तो करो solve, बताओ by 1 by 2. Don't do this mistake, okay? Please do remember this process and please revise this also. Next, the very important point, if A naught x, if it is nth order, right? Then also W of y1 y2 yn will be written as the coefficient of second highest order derivative divided by the coefficient of highest order derivative into dx. So please mark star here. Do remember whatever things I have talked today for linear homogeneous of the differential equation, like these all results can be extended to nth order differential equations, and then maybe 2, 3, 4 anything. So whatever we have learned, that will be applicable here also. For example, कैसे? Let if y1, y2, y3 are any 4 solutions of d4y over dx4 minus d2y over dx square plus 2dy over dx plus 3y equals to 0 with w of y1, y2, y3, y4 at the point 1 is 2. Then find, W means Wronskian. Then find Wronskian of y1, y2, y3, y4 at the point, any point, 7. Chaliye, tell me the answer of this question. Answer is just 20 seconds, not more than that. Please do reply. Every one of you, whoever attending the lecture, please do reply. Please reply. Time over. Chaliye, yes, time over. Compare this with this. क्या मिलेगा? A naught x का वैल्यू 1, हाईएस्ट ऑर्डर डेरिवेटिव. D3 है नहीं, तो A1 का वैल्यू 0. A1 is the coefficient of second highest order. A naught is the highest order. So W क्या मिल जाएगा? W of x will be c into e raised to the power 0 upon 1 into dx. That is c e raised to power 0. This is 0. E raised to power 0 is 1. So W at x is 1. किस पर चाहिए? W at 7 will be also 1 because it is constant. W at 2 lakh also 1. Is that clear or not? 20 seconds में हुआ कि नहीं? Tell me. Is it so? Any mistake is there? चलिए, यहां से Wx equals to C निकला है मेरे बच्चे, C into 1. ओके, अभी इनिशियल कंडीशन तो यूज करना पड़ेगा ना, ये वाला यूज कीजिए. यूजिंग W at 1 equals to 2. So what you will get? 2 equals C. अब x है नहीं तो x का वैल्यू 1 पुट करते, C का वैल्यू क्या मिल गया? 2. अब मिला आपको W at x is 2. So W किस पर पूछा था? 7 पर. So W at 7 is also 2. not 1. Okay, Pritam? C into 1 लिखा था. I had to use the initial condition as well. Is it clear to you all? Is there any doubt? Now you can solve questions from Wronskian as well. Fair? अच्छा चलो झूठ मूठ का एक क्वेश्चन और पूछ लेते हैं. देखते हैं. Let me ask some question. Let if by 1 comma by 2 by 3 are solutions of a naught x by triple dash plus a1x by double dash plus a2x by dash plus a3x by equals to 0, then which of the following can be the Wronskian of by 1 and by 2? Suppose that जो x आपका डोमेन है that is given from 0 to pi. The domain of is the open interval from 0 to pi. Then which of the following can be Wronskian of by 1 by 2? wx sin x हो सकता है, cos x हो सकता है. Give valid reasons. This is the probable question for your UPSC CSE. Please reply. Everyone, whoever attending the class, please reply. Let's see what you learned. Huh? Please reply. चलिए देखिएगा. Since x belongs to 0 to pi, so sin x is non-zero, right? For all x belongs to, so sin x can be the Wronskian. Number 1. Since x belongs to 0 comma pi, ठीक है? Let if Wronskian is cos x. Not possible. Why? Since cos pi by 4 non-zero, cos pi by 2 0. But what we have learned, Wronskian is either 0 for all x or non-zero for all x. So Wronskian for this domain cannot be cos x, because then in that case this Wronskian will be taking 0 as well as non-zero. But sin x is non-zero for this interval. Suppose that if I change x belongs to 0 set 2 pi, then ना तो sin x Wronskian किसी का हो सकता है, ना ही cos x. Neither sin x nor cos x, because in this interval sin x will take value 0 as well as non-zero. But Wronskian should be either 0 for all x or non-zero for all x. So in this case, the Wronskian cannot possible to be sin x or cos x. But for the question sin x, because in the question the domain is this, so for this sin x can be the possible Wronskian, but cos x cannot be. Clear? Please note down. So these are some basic concepts from the Wronskian. Today I have tried to summarize the chapter 1 with the singular solution. Then I started the higher order, gave you the introduction. Tomorrow we will start a fresh topic, that is how to solve higher order differential equation. What is CF and PI? Okay. It is not good to start a new topic today. We will start a fresh topic by tomorrow. Okay, Pritam? You have noted? Okay, chalo. Fair. चलिए, lectures will be continued. It will be always open. No issue. Good night, everyone. Good night. Take care. Sleep well. Good night. If you have any doubt, you can ask me. Rest. We'll meet by tomorrow. Good night. Children, good night. Good night.